sure that I leave some time for questions at the end of my session. So just give me a second here to flip and switch to slides, and then we can get started. All right. So as Sven has mentioned, design and build great web APIs. This is actually the theme of the last book I was working on. By the way, this is me. This is how you can find me on LinkedIn and GitHub and Twitter and YouTube. I would love to connect, learn what you're working on, what's a challenge for you in this API and services space. I'm always looking for feedback and new ideas to things to talk about. So as was already mentioned, this talk is actually taken from a book that I'm finishing up for pragmatic programmers. This week, I'm actually writing the very last chapter. It'll go into edits and be available in June. By the way, you'll see on this slide, and you'll get a copy of these slides, there's a discount code, Web 2020. That's 50% off this book. So we're, just for this session, we're offering a chance for you to pick up the book if you wish. You can actually pick up a book in beta mode right now and start reading it. You can sort of see, we say in English, how sausage is made, like all the details. Still got a few edits and bugs, but we'll be fixing it over the next month. Or you can just wait until it's released in June. All right, so I want to talk about this whole idea of designing and building APIs. It's a huge space, and I'm going to try to boil it down. And then boil it down to some key parts. I want to talk a little bit about some foundations. Then I want to go right into the design, build, release sort of history or life cycle that sort of makes sense. And then I want to talk about what happens after release. There's a lot that happens after release, and we'll get to talk about that as well. So let's jump right into this idea of foundations. Before we even get started on this idea of creating interfaces and APIs for services, what are some things that we need to focus on? And I want to talk about two particular things here. I want to talk about the idea of API first. What does API first mean? And I want to discuss in sort of general sense these three pillars: HTTP, the web, and REST, because they each contribute in an important way, but they contribute in a unique way. They cover a different space each time. So I first learned about this idea of API first. I first read about this in 2009 from Cass Thomas. I like Cass, I like his point of view on this. Identifying or defining key actors, determining what they expect to be able to do. What they expect to be able to do. Who's your audience and what are they trying to do? That's what API first is about. Let's design an interface, whether it's a visual interface or a machine interface. Let's design an interface that allows our key audience to do the things that they want to do, to solve the problems they want to solve. And that's a really good way, I think, to think about it. APIs exist to solve business problems. They exist to solve a particular problem. What is your problem? We need to onboard customers. We need to manage company customers. We need to manage all these kinds of things. And then you're designing for an audience. If I had an audience of JavaScript developers, I would design it differently than if I had an audience of PHP developers, or C# or Java or Go or Rust. And then finally, I want to use this idea of design first or design thinking. What's really going on here? We want to discover people's real problems. There's a great story, and it's sort of it's a bit frustrating but true. A good designer, once you invite them into the story, actually makes the whole situation more complex. They ask more questions. They get behind the scenes to design what's really going on, not just the surface. So design is really important, and designing up front and thinking about the APIs as this way to solve a business problem for a target audience is super important. Now, we've got some technical details to do with in the foundation as well, and that is how we're going to use these technical elements when we solve our business problem. And the most common way to solve it today in this API space is HTTP, which is a protocol. It involves things like URLs and messages and methods and status codes and all these other things. Those are very unique elements to HTTP. That's not the same set of elements as when you're using, say, TCP/IP, or you're using MQTT or CoAP or FTP or any other things, right? So keeping that protocol in mind is important, but we need to think of it as a technical detail, not as a design element. And that's a really important way to think about it. We're not designing a protocol. We're using the protocol in our API design. The web is a little bit different. The web is a common set of practices. It's based on an idea of separation of concerns. We've got layout in one place. We've got styling in another place. We've got script in another place. We don't use it all at the same time. We mix things. We have lots of different formats for images. We have the ability to actually embed code in the forms of containered items and things like that. So links and forms and separation of concerns is really what the web is about. And we'll need to think about those when we're creating our APIs. And then finally, we can use the term REST. REST is a style created by Roy Fielding and in the year 2000, 2001, when he was talking about how to program networks of machines. Not program a single machine, not program a single server, but networks of servers. And he had a really unique approach to describing this way of styling network architecture. He said you take a set of desired system properties like scalability and changeability and so on and so forth. You add to that a set of basic non-negotiable requirements, like it should be scalable at lots of levels, it needs to be easy to start, and so on and so forth. And in order to make all that work, you invent a bunch of constraints, of limits. You tell people, in order to get the properties I want for the requirements I need, you need to behave in a certain way. So Fielding invented a series of constraints, and we focus on those constraints a lot. It must be client server, it must be cacheable, it must be layered, and so on and so forth. Every URL is a unique resource. All these constraints, we don't always think about why they're there. They're there to establish the existence of properties based on requirements. But that's simply one style. The REST style is different than the GraphQL style, which is remote data access. It's different than remote execution styles like containers or VPNs or things like this. It's just one style. And in fact, we could have lots of different styles. We should have many more carefully designed styles where we know what properties we want, we match requirements and invent constraints. But we'll be using these as I go through this talk. The protocol, the practice, and the style. So solving business problems and then dealing with things like protocol and practice. That's sort of our foundation level. So with that in mind, let's talk about the design side. It might surprise you, it might not, it depends on how much you've seen me talk. Actually, I think design is most important in this story. The two things I think are most important, actually, design and release, not build. Well, design is incredibly important. There's a lot to do. I'm going to focus on three things here. The act of modeling your interfaces based on what you learned from your customers. The act of designing something that matches that model, like turning that model into something that's workable. And then the act of describing it in a very detailed and machine readable way. It's a great thinker by the name of Donald Norman wrote a book called The Design of Everyday Things. And he talks about a thing called the life cycle, or Norman's life cycle. And you can see this in the illustration here. We perceive our world, we make an interpretation, we have a goal in mind. We say, I need to turn the heat on, for example. So I interpret how warm or cold it is in the room, I compare it to my idea of what the goal is, and now I set a plan. I specify, oh, I'm gonna have to go turn the switch on, and then I actually perform that, and then I affect the world. And then I enter that bridge of evaluation to see if I've perceived that it's warmer here than it used to be. And this is a cycle. We go through this cycle every day, reading the newspaper, driving to work, turning on a light switch, cooking our meals, writing our code, solving problems every day, searching for a website. We search, we type in a search. Is that really the search we wanted? That's not the goal. Let me specify another search and do it again. And it turns out in our world, there are no straight lines. We don't actually go from step A to step B to step C. We actually go from our starting place and attempt something. And then we get the results and come back, and then we attempt something else, and then we attempt something else. We live in cycles or circles. And the way we can talk about that cycle or circle is to create what I call an API story. This is similar to a user story. I need to write down in prose what it is what is their goal? What is their method of execution? What is their method of determining whether or not they've reached that goal? So this is a really simple example of an API story. We need to keep, story has a handful of things, such as its purpose, a simple sentence. We need to keep track of companies. This is from my imaginary company called BigCo. There's data we collect, there are actions we take, and there may be processing rules. There may also even be some other rules about things like duplications and constraints and things like that. But writing a story is super important. This is the first step in communicating with others about what you're doing. And notice this isn't written in any technical jargon. It's written in a language that everyone can contribute to. In the book, I talk about how we actually collect this information from people, reflect it back to them, and write the story. But the idea is to get this story first. Then that gives us a chance to talk about designing. So I can use what I call design thinking. We talked about this earlier. Ask questions, write things down, discover what's really behind things. We talk about this idea of solving a business problem. Clayton Christensen in his Innovator's Dilemma talk about jobs to be done. What are we trying to accomplish here? We're trying to keep track of customers. We're trying to onboard new customers, whatever the case may be. There are lots of things that come out of this design session. The description, the narration I talked about, the definitions, which we'll talk about a little bit later, the documentation, which is actually used by people who are going to use your API, and an API diagram, an actual diagram, a visual diagram. It's important to have not just the written story, but also a diagram. So this is a simple diagram that talks about the things we need to do. We need to be able to list and filter and read and update and create and change and all sorts of other things. And this gives us a super simple way to start. In the book, I talk about several layers of this diagram. This is sort of like the middle layer, but you can get a lot more detailed in the process. Eventually, we have to describe it in a very detailed way. This is way too general. That very detailed way is what I call an API description. A description is not a definition, but it describes everything, every property, and every action in a specific way. For instance, in our company management, we may have 12 properties, such as company name and address and email and postal code and country and so on and so forth. But we have several actions, such as list and filter and change status and so on and so forth. We document all of these things in a machine-readable way. Around 2014, I and a few friends, Leonard Richardson and Mark Foster, started working on a language called the Application Level Profile Semantics, or ALPS language. And this is what I advocate using in the book. There are other ones. Dublin Core has a thing called DCAP. There are some other competitors to this description space. But what's powerful is that you can use the same description to generate lots of definitions. I did a talk recently this year for GoTo, as a matter of fact, about how you can use a utility I wrote called Unified to turn ALPS into an open API or a GraphQL set or async API or a protobuf object or even generate WSDL. But a description is this technology agnostic way of describing the API that we can pass off. You can think of it as a sort of a blueprint that we pass off to others. So this is an example of an ALPS document. It operates on a thing called descriptors, and actions have things like safe and unsafe and idempotent, and then data is simply semantic elements. You can sort of look more about it in the repo later on. So designing APIs is really about modeling for a story, creating a diagram, and then creating a machine level description. And that's really important. That sets the tone. That gives you enough collateral to turn over to an individual to actually start building. And that's what building is about. And you may be the same person building, but you may have to give it to another team. You may have gotten a designer team to help you, and now you're ready to build. And I like to talk about building in 3 different steps: sketching and prototyping before actually constructing or building. And I'll talk a little bit about what each of these. Frank Gehry is a fantastic physical architect, and he's famous for his sketches. He would sketch out, somebody said, I need an entryway. So he would sketch out lots of different examples of what that entryway would look like until he found one that was interesting. He would explore possibilities. Is it ornate? Is it complex? Is it simple? Is it an outside garden? Is it stone? Is it wood? All these things. So sketches are a great way to explore what an API might possibly look like. This is what a record looks like in a response. This is what an input looks like in a request. This is what a filter looks like. I use a language called API Blueprint for most of my sketches because sketches are very simple. I just need to write them quickly, and they work on a thing called Markdown. So this is actually an API Blueprint document. You can look up API Blueprint to find more about it. I'm sketching out responses for like a credit check service. This is another one of the imaginary services, and what a single record and what a list looks like and what the URLs look like. And then I can press F5 and I have a running mock right away. I can see exactly what that looks like by visiting the various URLs. Now it's just a sketch. It's just a piece of paper. It's just scribbles. It's not functional in any way, but I can test things out and show it to people and see if that really makes sense to them. Now, once I get past sketching, I throw away all the ones I wasn't interested in. I keep the one that seemed to work. I want to build a prototype. This is a picture of a prototype here on the screen. This is a prototype of a monument at Mount Rushmore. It's built to 1/12 scale. Borglum is a fantastic, he's the artist who designed, the sculptor who designed the monument. And he has a fantastic sort of lean architecture story that I could tell someday about how he started out. He negotiated about which presidents would be here in what order and so on and so forth until he got enough investors. And then he built the scale model so he could explore all the details. That's what prototyping is about, exploring all of the details, figuring out all the little minor elements before you get started so you don't have surprises. Can you imagine doing a sculpture that's going to be as large, this is the 1/12 scale version, as large as he built, and he has to blow up parts of a mountain. You don't want to screw that up. You don't want to blow up the wrong thing. So prototypes help you expose all the details, find the corner cases. I use OpenAPI to do my prototyping because OpenAPIs are very, very detailed. I can write a sketch in a few minutes. It takes me a couple of hours to write an OpenAPI. I can write a series of sketches over the space of several days. It will take me a week to write a good OpenAPI spec. Now, this is an OpenAPI 3 document. It's actually for another one of the big services. And you can see I even have a mock server up and running so I can get a very detailed experience. I can actually return 400s and so on and so forth. I can explore lots of objects and other things inside my OpenAPI. So OpenAPI is meant to be tested and tested over and over again until I finally fall on the one that I think is going to make sense. Then I'm ready to actually build. Now I can build my API. Building for me needs to be a repeatable process. Building should be boring. We've discovered all the problems. I'm not going to go dig a big hole and order a bunch of girders and cement and not know exactly what my plan is. I'm going to have that all worked out ahead of time. There's more than enough excitement just constructing the building. I don't need to actually be designing it in process. So building is actually converting that prototype and that design into running code. Over the years, I write a lot of APIs. I write a lot of proof of concept APIs, a lot of tests, a lot of examples, and a lot of small APIs just to get things done every day. And I've developed a little library I call the Dart library, which focuses very much on the design elements we talked about before. What are the data properties? What are the actions? Those are the internal elements. What are the resources externally that I need to expose, if any? Like maybe it's just an endpoint for WSDL or for messaging. What are the representations? What are the messages that have to be sent back and forth? And then what are the transitions? What are the links and forms that actually animate the code? My APIs don't just contain data unless it's just a CSV. Instead, they actually contain instructions, transitions on how it can go to the next step. Here's your data. Here's how you can filter it. Here's your record. Here's how you can edit it. And that's what the transitions are about. So the Dart library is pretty important. I just want to spend a few minutes talking about Dart a little bit just to make sure. So it's a process for designing interfaces in a very specific way. So you can do things like design all the properties for an interface. Remember, we're not designing a database, we're designing an interface. So here are all the properties for an onboarding app, and here are the fields that are required, and here are the enumerators so that I can actually check and make sure that you're actually sending me data that's correct. And here are the default values for things that you don't supply. I can do all of these things to manage my interface. Now, actually, the actions are really important. The actions are the functions. They're the things we actually do. Sometimes the actions are simply just reading and writing and returning data. So I want to go ahead and, in this case, I want to read an item and find certain fields to return. And if not, I just do something else. But I could do more sophisticated things. I can actually call other services, make computations, and so on and so forth. Now, those are the internal elements. The external elements actually start with creating resources that people can use. So I make declarations. I use the Express a lot in Node because it's really easy, it's fast, but there are lots of replacements, lots of similar things that you could put together. So I expose all of these elements, and notice that the same URLs might support different actions. That's kind of the way it works in Express. But then I also need to formulate representations. How do I represent the data coming back? Here's a simple JSON template for the data. I use the data in a very generic way. I have a thing called a representation, internal representation of the data object. And then I use templates to generate other representations. So I can represent this as JSON or HTML or HAL or Uber or Mason or collection JSON or WSDL as like SOAP XML or any other simple file format, even YAML or something like that. So it's really important to separate representation responses from your objects. So it doesn't matter what your object is, you send it to the representer and it comes back in the format requested. Then finally, as I mentioned before, every action needs to be documented as well as a transition. So here's the transition for adding account. It has a certain URL, it has a title, rels, tags, a method, and it takes certain properties. And those properties might already exist and they would be filled in here as macros, so on and so forth. So I define all of these things, data and actions on the inside, resources, representations, and transitions for the outside. And that's how you put together your build. Often that build is relatively tedious. It's just putting things together, but there's still a little creativity involved. So I use sketching to explore with apiary blueprint. I use prototyping to expose details and test with OpenAPI. And then I translate all of that using Node and this Dart framework into a working building application. Now, there are lots of other things that go on. I needed to kind of create a group marker. So now I'm going to talk about releasing. And in the releasing, I want to talk about three things: testing, security, and deployment. Now, in reality, all through the process of building, I'd be working on testing. And even in design phase, I'd be working on security. But, you know, it's a linear book. I got to make some decisions somewhere. So I bucketed testing and security in the release phase. So testing is really, testing APIs is kind of interesting. You want to do more, think about it differently. You want to test the interface, not the code. I don't care if you're using Express or Node or Java or C# or PHP or Python. I don't care what you're using inside. What I care is the promises of the interface and the behavior of that interface. So I need to do several things. It's also really important for me to focus on what I call happy path and sad path tests. Happy path tests are things that should return 200s. I should be able to read a record if it's a valid record. I should be able to get a list. I should be able to do a filter and so on and so forth. But it's also important to focus on sad path tests. I should get a 400 error if I try to create a record that's a duplicate, or if I try to create a record that has an invalid enumerator and so on and so forth. So I need to write tests both for the happy and the sad path. Now, the tool that I use for this writing is called Postman. I like Postman because it's a pretty extensive collection. They've got some great scripting tools in it. I use a library called Chai.js, which is a very behavior-driven a library, which I like. But what I really want is a command line version of Postman, and that was actually created called Newman. So I can actually invoke all my Postman tests at the command line using APIs and a tool called Newman. So that's a really important element. I also do a lot of pre-request scripting in Postman. If you've used Postman a lot, you kind of know what I mean. I have a set of utilities and libraries that make things super easy. We won't get a chance to talk about it here, but I typically do my Postman tests in groups. Each one tests the protocol aspect, like its status and headers and whether or not I got the right data property or representation back. I also do things such as structure, like does it have the right elements in the message? And then I do things such as value. So does that structure contain certain values? So that's lots of scripting. And you can see more in the book that I use. So I want to talk just a little bit briefly about security. We won't have time to dig into it here. I want to make sure we have time for questions. But I focus on three things in the book. That's encryption, identity, and control. So encryption is basically HTTPS, TLS encryption. That's a foundation of things. Identity and access control I handle through OpenAuth and Java JSON Web Tokens. And I use machine-to-machine authorization for APIs, which means client credentials, which means I have sort of an identifier that I pass along, and then I can set up rights on that identifier, and I have to get a token before I begin. I use Auth0 as a provider, and I use a series of utilities that make it easy for me to get tokens. As a matter of fact, I even automated token retrieval in Postman to make it easy as well. OpenAuth in general is kind of fidgety. I won't dwell a lot on this. Probably a lot of us have seen this, but I have to get a client. If I want to talk to a service, the first thing I do is I have to talk to my provider to log in and get a token, get that token back, pass the token in step 3 to get a resource. Then that token has to get validated by my service, and then when the validation comes back, the resource comes back. It can get a bit fiddly, but this does scale over time, which is really, really important. There are lots of other aspects to this whole idea of security that we could explore in another talk sometime, including the idea of how you scale security for services you've never met, services that you trust the provider, but you don't know the service. And we can talk about those at another time. I want to touch on deployment. So I want to automate deployment as much as I can. In the book, I talk about the difference between continuous integration, continuous delivery, and continuous deployment. Integration means I can check in, I can code and check in and get some basic tests, and then I manually take it from there. Continuous delivery means I can actually run the test and then put that into staging somewhere automatically, maybe if the tests all pass. And then finally, it can get put into deployment, production manually. Continuous deployment is possible in some cases, and that is I can go from check-in to actual production with little to no effort. So there's lots of things that go on in that space, but the real key to all of this is to automate every possible step you can. Automation improves safety. Automation is there for safety, not speed. I want to be able to recreate this over and over and over again. There are lots of, this is the whole DevOps, entryway. This is sort of the gateway drug for DevOps. There's lots going on here. I actually use a super simple way of doing all this with Heroku. I use Heroku for my hosting of my APIs, and I can just do it via a git push. I can actually say git push Heroku master, and I'm off and running. Heroku will actually build all my environments, create their container, populate it with my code, run a series of tests I tell it to run, and if it passes, put it into production. If it doesn't, it'll back all of that out, which is really cool. I even do more than this. I script the Heroku, so I run my local test. If they pass at check-in, if they pass, then it goes on to post to Heroku. If Heroku passes, then I run my remote test, and then I know it's done and in place. All of that's about automation. So this is a little bit of me running tests, and you can see down at the bottom there, I had a little deploy fail as an example. So that means it backed out all these other steps along the way. Testing the interface and behavior with Postman, using client credentials with Java Web Tokens with my Auth0, and automating your deployments, for example, with Heroku Git Push, are all steps in that releasing space. And again, remember that this releasing might actually be going on with a different team than building. Some of us are full stack developers, some of us work on a team that has a member of every step along the way, but others have to pass it off. So that's a part that we have to deal with. I want to talk about one more thing after release. And that is actually, I think, in a lot of ways, the most important thing, and that is modifying. So once you get it into production, it doesn't end there, it starts there. Now you've got lots of other things you need to do. And I just want to talk about some basic principles about updating production APIs, because it's a really important element. The first principle is to do no harm. In other words, none of your updates should break existing customers. When you're in a single company or a single team, maybe everybody knows what you did. But if you're on the web, if you're in a large organization, you may have people using this API that you've never met, and you don't know why they're using them. So it's really important not to break your existing API. You may have to fork your API. You may have to actually break off a version of it, an addition for another release somewhere along the way. It's also important to know when to say no. Sometimes people ask for a feature or an update or a change. It's just not worth it to disrupt an existing API that's making money or that's stable in order to add a feature. So you just need to say no. But if you do say no, there are basically 3 rules. First of all, when you design an API, you can't take anything away. If you promised a URL, if you promised a response, if you promised a format, a body, a status, you can't take that away. You can't remove it. You're going to break somebody when you do that. You can't break somebody. You can't redefine things. You can't invent new reasons to use the third argument. It used to mean the number of users. Now it means the number of pages. No, that's going to break somebody. And anything you add, new arguments, new URLs, new responses, they all have to be optional. You can't create a new required field in a form in a transition. You can't say now you must return the zip code even though we didn't ask for it last time. That's going to break somebody. Take nothing away, don't redefine. Additions are optional. That's the design principle. So maybe you're implementing your new parts, you add things, that's fine. How do you test it? Well, first of all, the way you test your new release is to use all the existing tests first. You don't rewrite the test, you use the existing test. That's a way to guarantee that you're not breaking anybody. Then you add new tests for each release for the features that if you added new URLs, new behaviors, new possibilities, you write new tests. So you accrete all of these tests from all of the releases together and you run all of them. You do not rewrite them. Rewriting them is really the wrong way to go. When it's time to release an update, the first thing you have to be able to do is actually be able to reverse it. So if you put it in production and it doesn't work, you have to actually reverse it out in a matter of seconds. That's what Heroku does. That's what you need to do as well. You need to favor side-by-side releases. You put release 1 and release 2 of the customer API into production. That's really, really important. Now people who want to use release 2 can start using it. People who want to stick with release 1 can stick with it. It's really not a good idea to overwrite releases, to simply replace release 1 with release 2. There is one exception, and that's when you're using a highly structured format like HTML or collection JSON or Siren, where clients actually know how to navigate the document space. That's why you rarely see HTML websites say, hey, please go to this new URL for our new website. They don't do that. They actually just overwrite their existing release. And that's because the client, the browser, won't break when they do that. Now, we might get frustrated that we can't find our content, but that's a human problem. That's a different problem. So the only time you should be overwriting releases are when you have a highly structured hypermedia type and you know you've got clients that are stable. That's pretty rare. So favor side-by-side releases. And finally, eventually, you're going to need to shut down an API. What do you do when you do shutdowns? You have a bunch of people that depend on you. You should consider putting the code in the public domain so that somebody else can mount a new one. Maybe you can't do the code because it's private. At least open source the interface. Take the same design documents we talked about before, the story, the diagram, and the description, and maybe even the definition for various formats, and put that in the open source so other people can do it. If you close an API, make sure that people can recover their data. Most APIs, people are just reading, but if they're writing, let them recover their data. And then mark your site 410 gone. Use the status code that says, this is no longer here. I usually return an error response in 410, problems plus JSON error type, which includes a description to at least one link that explains what happened. Maybe you didn't get to somebody, maybe it's a public API, maybe even points to the public domain code or the open source interface that they can use in order to create their own version of that API. So first, do no harm, use your breaking changes in your design, use all the old tests, favor side-by-side releases, and shut down responsibly. That's how you complete the cycle of modifying an API. Okay, so quick review. You want to solve business problems with a protocol, a practice, and a style. You want to use stories, diagrams, descriptions, sketches, prototypes, and then detailed builds. And then test, secure, and deploy your API, including the notion of even modifying them over time. So don't forget, we're identifying key actors, determining what they want to do. That's our job when we create APIs. APIs often stretch boundaries. They cross the various services. They're aggregators. They are the user experience for developers that help solve problems. So I'll post all the slides at this URL, and I'll share this URL with the group, with Sven and the group. I want to thank you very much. Hopefully, we've got time for a few questions. I'm going to go ahead and turn my slides off, and then I can see you, and you can see me, and then we can take a few questions. Oh, good. It looks like we have lots of questions.
Actually, not so many. We have two questions. By the way,
Okay.
thank you very much. Thank you very much, Mike, for your talk. So Christian asked, what is your advice on using REST versus GraphQL versus gRPC? When to use what?
Right. Yeah, so it's an excellent question. It happens all the time. When each is appropriate, right? So it turns out a lot of people are going to want to be using REST because they're familiar with it already, right? Or they want to use just the simple CRUD version of it, right? But if you've got a case where in GraphQL, like a good example is Facebook created GraphQL because their backend couldn't keep up with the demands for front-end changes. Front-end says, we need a resource like this that has these properties and those properties. And the backend couldn't keep building. So they just built a query database, right? A database query model that was sort of generic. There have been a handful of these created in the past. So that solves the problem. Who's our audience and what's our problem? At Facebook, the audience was internal developers creating outward-facing apps. So I think GraphQL works really well in that sense when you're solving an internal problem. I don't think GraphQL works very well on exposed APIs on the internet. Got caching problems, you got security problems, you have shared model problems. You have to actually, if you change the model, you can break a lot of people. So I think it works really well internally, like inside a company. I'm not sure it works really well outside. gRPC is a little bit different. As we make our messages smaller and smaller, as we're doing more event-based, the idea of REST was that we'd have very large documents and you'd be able to cache them. That's pretty hard to do in an event-based system when you're using things like Kafka or event notifications or something like that. So gRPC makes a lot more sense in that world. I also like that gRPC actually contains a lot of, there's a lot of things built in to help you follow the 3 rules I talked about, add things and not take things away and not redefine things and so on and so forth. So it's very good at that. So often as you're getting to more in eventing, I think we're going to get back to RPC modeling. I think the challenges for RPC primarily are scalability, but we seem to be beating most of that with cheap resources. So it looks like it should work fine. I've actually done the same app in all 3 of those. It means you implement them differently. You make minor design decisions, but they all work pretty well the same.
All right. So Thomas asked, do you have a recommended resource that goes into depth regarding security?
There's one that's at the tip of my tongue. I can't remember it. I may have to get back to you, Sven, and send this to you. There was a short report that was written by a colleague of mine at Computer Associates on modeling security for microservices. The challenge for microservices is we need shared identity, but we need localized access control, right? Every service should manage its own access control, especially on the web. You can't count on like an overall cover. And there was a great paper, and there's a theory called Dharma, D-H-A-R-M-A, which covers some of this. Matthew McClarty wrote it. I will see if I can find it while we're having the other talk, and then I'll paste it into the chat window if I can find it. That would be a place that I would say start. Personally, I actually find the Auth0 resources pretty good if you're using OpenAuth, OAuth stuff. So there's some good sources there, but I'll see if I can find the book that I was thinking of. That would be my first one anyway.
Yeah. That reminds me that I also once did a podcast with Sam Newman about microservice security, where we talked about that stuff as well. I mean, it was quite, it was a bit broader, but I can also paste the link to that podcast. It has also further resources.
Sam's research, that's a good one, Sven. Sam's resource on building microservices might be good. Chris Richardson's book on microservice patterns might be pretty good as well. So there are a couple of possibilities there. Those are good. Those are all really good ones.
All right. So then how to do side-by-side deployment? That's Christoph is asking. Different ports, URL versioning, header versioning, something else?
Yeah. So typically side-by-sides are done in RESTful services. They're done by URLs, right? So whether you put a V1 in the URL, that's a new URL. whether you rename it somewhere, that's a new URL, whether you change, you could change the authority, like, you know, the domain side, like apis.examples.org, whack customers. You can make it apis to dot, you know, it's the URL that you're going to change in REST. Typically in async services, it would be a port number. You might even be able to just do it as a message number in an async service or a gRPC. But it's usually done by URL. And that's really all we're doing when we add Vs and 2s and 3s to URLs, is we're creating URLs. The challenge is, as you do side-by-side, you expand the footprint of your API, right? So now I've got version 1 and version 2 and version 3, and they're really forks, right? Because they're not necessarily backward compatible. And it gets bigger and bigger. So eventually you've got to get rid of some of the old ones. I had a customer that was running on version 2, their URL said version 2. I said, oh, what happened to version 1? And they said, well, actually we're on version 7, but we can't change the URLs anymore because of our customers. So it's all relative in some space, but side-by-side is typically done with URLs.
Okay. Michael is asking, isn't your design process another big upfront design approach? Would you have expected some cycles during the process?
Yeah, that's excellent. So I made a big deal about cycling the backside, the security and testing, but I didn't talk about cycling the front side. You're exactly correct. It needs to be the same kind of organic level. And I do talk a little bit about that in the book. You want to avoid a lot of upfront in the design as well, but you want to make sure you don't start off on a journey without everything in your kit bag, right? You want to make sure you've got enough to get started. So you can definitely do that. So you can do lean versions of that same space. Just know that as you release public APIs, people get dependent on things. And this goes back to our releasing strategy or our versioning strategy before. So often you have like beta versions, you test things out and you do that whole cycle that we talked about. Get an idea of what the customer wants, sketch it, prototype it. You might even release it, but a lot of times you can do prototypes before you actually do a final release. So that's a really, really good point. You want to avoid big upfront in every step along the way. That's good.
Okay. There was one question from Thomas. He tried out the link, the 2020 Cologne, and I also tried it out. It somehow it doesn't work as expected. So I would just say we check it later and just publish it on the website. So now maybe the last question from Olaf, and then we move on to Lars. But keep in mind, Mike's still around here, and after Lars' talk, we can also have a joint, let's say, Q&A. So Olaf asks, if an organization would start the API journey and building different APIs in independent teams, what advice would you give to them for having a consistent experience throughout the organization?
Okay, so there are a couple of levels of that, and I'll just sort of take two to start. So one is the experience of actually designing and building and releasing and having consistency there, right? That's sort of the internal or the back office experience that gives you transferable skills. So adopting a pattern like the one I talk about in the book, where you produce certain assets in the design phase, certain assets in build, certain assets in release, that's one way to get consistency, so that if I move from one team to another, I recognize, oh, I'm going to focus on testing. I'm going to focus on description language. I'm going to focus on generating a definition. And that makes sense throughout. You can even dashboard that, so you actually know what each team is doing. Are they on the build phase, the design phase? Have they produced these assets? There's also the consumption consistency, right? Which may also be, how do I know that anybody's going to understand this API at the end? And if you adopt the strategy in the build of keeping representations fluid, in other words, don't have an argument about what format you're going to use, support multiple formats and negotiable formats. So that's one way to keep consistency. The second one, which I didn't discuss here, is to use a common vocabulary or a common set of terms. We all use given name, not first name. We all use family name, not last name when we're on the web. So a lot of organizations will actually highly constrain the vocabulary of messages so that you always use the same terms all the time. So I know what first name and family name, and I know given name and family name and postal code mean, no matter what API I'm using. So by being flexible about formats, and being strict about vocabulary, you can create a consistency that makes it possible to know that you'll have compatibility even when you make changes in the future. We can talk more about that, but those are the two things that I see companies doing most often.
All right, cool. Thank you. Yeah, you will still be around.
Yes.
Yeah, let's directly move to our next speaker, who dives a little bit more into the details on testing. So it's, I welcome Lars Wolff, who is the co-founder and, oops, now my, who is the co-founder and CEO of StormForger, which is a load and performance testing SaaS provider. No pressure, Lars, but you know, he's in general a great guy with lots of talents in strategy, goals, creation, communication, but of course also, and most of it, load and performance testing. So what will he talk about? He will talk about how you can ensure reliable applications, API, you name it, by continuously testing performance characteristics. You know what I mean, characteristics. Also here, a little teaser. So if you like to learn more about what they are doing, I highly recommend it. So I work with them now for many months already. And you can visit their website, stormforger.com, and you can just request a demo. I will also post the link on our website. So, and again, now without further ado, welcome Lars.
Hey there. So I'm not sure you can see my slide. You can see the test image.
Yes.
Yes. Okay. So as Sven already said, my talk is called Perf Test Early and Perf Test Often, or ensure the reliability of your application and of course your APIs with continuous testing of performance characteristics. So as said in the attendees, some people are here which I already know, but however, my name is Lars. I'm the co-founder and CEO of StormForger, a software as a service for load and performance testing. You can look me up the web, of course, and I've the following journey. I started software development and engineering. I moved over to consulting. I realized that I will move over to agile coaching because not all the problems are only technical wise and maybe more organizational wise. But deep in my heart, it was always that I want to deliver stuff and ship it in a specific quality. And that actually lead me to performance testing, because performance testing is one of the things you can and should make for to make sure that you deliver the right quality you actually want to have. So now let's start with the talk. So welcome to a world of complex systems. I don't know if you know that picture. This is the LHC in CERN. And I want to bring your look down to the bottom of the picture. There's a tiny man standing over there with a yellow hat on. So this is a pretty massive machine. I have no clue what this thing is actually doing. But the physics say complex systems are systems with a high interdependency. And this is actually things we deal with every day, right? And I want to give you a better picture. So this is the cloud native landscape. So all the problems we're dealing with every day, either if we build something or either if we run it, there is pretty much a solution out there. We have colorful logos for that. And if you just look on this picture, you see, okay, this is massive. And this is one of the core problems we actually have to deal with every day. And I always have to do that. So if you look over there at the red arrow, this is tiny little StormForger with our black anvil. And I just want to make sure that you understand, okay, it's really massive, it's really small. And by the way, on the right corner in the bottom, there's serverless. There's their own landscape for the serverless world. However, one thing is important, in my point of view, in the cloud native landscape right now, all stuff about QA and testing is kind of underrepresented. So the category just changed from monitoring and observability to observability and analysis, but I think we will move forward there. So why are actually building this complex systems, or why do we have them? So we are right now in a situation that we need a lot of innovation at a quite high pace. And this is not only like a business requirement, it's also like a requirement of technology change as well. So we want to solve our problems with the newest technology, the best technology. Like we just had the discussion about the old RESTful or REST designing APIs or RESTful designing APIs, or should we use GraphQL today because it's the new one? And so there are a lot of challenges out there. When it comes to talk about the reliability of your system, your application on a system and your APIs, it often boils down to one of the following pillars. So there's one thing which is performance in general. Performance matters. There's scalability, especially for any application in the cloud. We have always reliability because reliability is simply not negotiable. I don't know nobody who want to deploy a system anywhere which is not reliable. And then there's this, of course, business need, which is called cost efficiency. We're not talking about always only save money, but spend the budgets for the right thing and know actually where you're spending the budgets. And with that all in mind, like having high complexity, we need the high speed. We have a lot of challenging situations to make sure that we have reliable systems. It's only possible if we actually have automated testing. And I think all of you remember, so we started to do that and we learned it the hard way, maybe 15, maybe 20 years ago, when we all moved to have automated functional testing. So Mike was talking about Postman, which is like the first thing we can save our test there and test locally the features we create and remove this further in bigger test suites. And you maybe also remember this was hard times. I don't know about you, but for me, when I did like the first test of features we created beforehand, it was like really pain to do it and make it always run automatically. And when it comes to non-functional requirements, I think we're still on a run. And there's there's the upcoming term DevSecOps, which is the logic that we of course need more security in DevOps movement, the same as we need more non-functional requirements or testing of a non-functional requirement in DevOps movements, because we want to make sure that our systems are always reliable and reachable. So now is the question, why, or what is the problem, why it's so hard to do it? So in general, performance testing just is simply super hard. So the reason for that, there are plenty of reasons out there, but one reason is you have a lot of organizational obstacles. You need testing goals and a scope. You need that always, but it's not easier for non-functional requirements. You need the visibility in your systems. That means you need good logging and good monitoring tools. You, of course, need the right tool for the job. To be honest, of course, my beloved tool is StormForger because our company, but there are plenty of tools out there to do it. But I also see that a lot of people are, first of all, deep dive in what kind of tools are out there instead of just start testing. And there is the next still human thingy. It's not that hard to get started with it because we have we may be kind of afraid to get started with testing of non-functional requirements. Furthermore, especially in our complex field in software engineering for digital products in the cloud, this is the field I'm thinking of right now, is that we must do it in a regular and automated way because we still need the high speed and we need a high quality. We cannot deploy something and deal with it that it is down. And back in the days, maybe we could do that, or actually we did it. And also complexity means also, and it inherits that we have their known unknowns. And in terms of confidence, this is first of all not a problem because we know there is an impact and we know this impact maybe is uncertain, but I think most of the people feel confident that there is an uncertain impact and they will deal with it. But if you have the complexity I was talking about in the very beginning, this also means that it inherits a lot of unknowns. And that means that the impact of stuff which can happen is simply unpredictable. And this is bad, especially if you in an organization which is fastly moving, have several deployments in a short term, using the cloud, using different services from cloud providers, or just a complex ecosystem at all. So the challenge now is, of course, let's make performance testing easier and make sure that we can test in an automated way. I can later tell in the Q&A what stuff we experience to do that, but I want to show you some stuff, some points, which is, let's call it approach, learnings from the last year here, how to actually get started. And even if you already doing it, that's great, but please double check with the list I give you. And also I welcome any feedback of stuff you think I missed there. So people are always talking about any requirements, and I learned in the last years that it's always super helpful to have a vision and mission, which maybe includes your SLAs and your objectives, but it's really better for the whole organization to think in something like a vision of like we want to be the fastest and most reliable system in the world, than giving somebody like an objective and the SLA, because SLAs and objectives are most of the time, if not in a legal language, they're often in a technical language, and people from the business side actually don't really want to deal with this stuff like this. Further, to really define requirements, it's really hard to do this for an organization, even as a small team or a big organization with big teams. It's hard to define these requirements because you are moving that fast. I mean, the businesses are changing sometimes in weeks or even days or over the weekend, and you cannot just rely on the requirements you actually had the day before. So you have to learn with that, and it's hard to define them and keep track on it and redefine them. Of course, you have a tool decision. I really want to make sure that you do not spend so much time on really deciding for the tool. Please spend more time on iterating on the problem you actually want to test. So you need something like easy test case management. Again, think of functional testing. It took us like years until we had the concepts of how we do actually testing for functional requirements, having the right structure for unit tests and integration tests and the right test suite and so on and so on. And the one most important thing for performance tests in general is pragmatism over perfection. So most of us as engineers, I mean, the same as we can build our own load generator, we of course want to have like the perfect test scenario for my use case because I know the use case the best because I created it. But if it comes to like the testing of non-functional requirements, first of all, please focus on the happy path and still have in mind that pragmatism over perfection is the way to go. And then maybe you move away from some kind of like an off happy path or something aside, or maybe you learn how your users actually really use your API or application out there, because it's not that uncommon that your impression how people will use that or the API is actually used is different than it is actually used. And then maybe or maybe not, you will come to a fully fledged like 100% test coverage. Maybe I don't know if you have that even in functional testing. Okay, and the last point is, since for different reasons, performance testing is kind of complicated, beginning with creating your load generator cluster and deploying test cases and run the test, it's really important that you automate it and have continuous feedback. So Mike said that before, it gives you more confidence and makes safe that you have less failures if you have the automation of tests like this, and you can make sure and learn from the data from regular running tests here. So the common conclusion, as in the talk title, is that one, please perf test early and perf test often, as you can also see in the back here. And it's not only me, of course, who's saying that, but I met a lot of people who had a lot of pain in production and learned the hard way, okay, we should have tested that before. And even a lot of people from the business side were saying, okay, if we had just tested that before and invested that time, we probably had made more money. And in the end, it's all about to get somehow the change to understand the behavior of your application, the infrastructure you run your application on, and maybe even like the ecosystem you're using there. I'm talking about third parties or services from cloud providers, and all of these behave differently. I will come to that back in the end, of course, but one thing again, like all the platform as a services, I found it really helpful that we have this out there, and it's really great. But I also saw some clients and some products who had problems in using that. And it's not the problem of the platform as a service itself. The problem is that we did not have the time to really work on the stuff we want to do that, and did not really learn how to use the platform as a service. So to get this more in a deep dive, as Sven said, by the way, I will not do like a super real deep dive, but I will. I want to end with a kind of an example how to get started and things to first of all take care of, and also show how easy it is. And it's an easy example. Let's imagine a flower shop in your head where you just can order flowers. And this flowers in different colors, flowers in bouquets. And this flower shop is, of course, reachable as via a website and has also a mobile app. And we easily come to the problem that you, on the one side, you have like take care of the website. On the other side, you have to take care of the API, and maybe the website is using the API and so on. You can imagine the complexity of that for yourself. But to get started with that is the first impression that we all know. If we have a web shop, somebody maybe visits your web shop and want to see all the flowers, like the product listing, the flower listing in this case. And of course, somebody will check out, not check out in the sense of buying it. It will, somebody will have a look at one flower detail. So this is the very basiest thing somebody can do with a flower shop. And I know this is not the style we are thinking about our flower shop every day when we're building it. And that's the problem. That's what I mean with pragmatism over perfection. Start at the really smallest thing. And the smallest thing is, we know product listing or flower listing here and a detail listing. And when you create a session with that, like a scenario to load test it, and by the way, as you see, I show code from StormForger here to create test scenarios, but to be honest, you can use other products out there, which is pretty much like the same way, but when you have a product where you can actually use code to describe your test cases, of course. So when you do this very first step, you immediately realize that when you want to request like a flower detail page or the entry of all the flower details, that you of course need some kind of test data. In this case, like just simply the flower IDs, and probably it will not fit to just use a random number to hit some or the right flowers you actually want to check. And this is like the first learning you have with that scenario. The second scenario is that you of course have to ask yourself, how much traffic actually do I want to simulate to check out the performance, learn about the scalability of my system, and actually determine the reliability in different use cases. And when it comes to that point, it's always get funny because people from operational side will say we can check out the logs, and that's true. And people from the business side say, okay, I can check out my favorite tracking tool, and that's also true. And if you compare the numbers, they completely looked at the different stuff, because like the levels of it, how they look at it, and how they actually track it is different. So this is the first problem which you will learn as a team, that you have to find out, okay, what is the numbers, the source of truth of numbers, for example, and what are actually the numbers you want to deal with. I always recommend, because like our approach is to think it from a user side, in, let's say in a user journey, that you actually ask analytics or business intelligence of your company, okay, what maybe is the usage, the highest number of a week, or how many users do we have, whatever is the good question for your specific test case. And if you just ask that question, you will immediately realize that the people, because it's like their business, they will respond with a lot of more information. If you just ask, okay, what is the highest numbers of visits a week? Somebody from analytics, you will receive a screenshot where you also see, okay, we have like so many checkouts, which means we have that conversion rate, and also the people are really happy to talk about their data. But maybe you did not really talk with these people about the data until this moment. So whatever, with that numbers, we can create like a traffic model, which you can use in a load generator to actually create traffic later. And we also have to think a bit more, and we realize, okay, if we really want to get started to test it now, we actually need something we can test against. And the next problem here is that most of the people maybe have like a QA system or a test environment where they can test against, but maybe it's not productional, the same size as production. Or if they have an environment with the same size as production, they probably face the problem that it is not the same releases as production because it's complicated too. Or third time, they realize, okay, we cannot even spin up like a QA system or a test environment because production is our only single point of truth for what reason ever. And I mean, like, you can imagine there's beneath the 3 points, there's a lot of possibilities how you can do it. So however, at one point you have to decide where you test against. And of course you have to challenge your target system with the numbers. So you cannot, of course, not test production style numbers against your maybe half of the size production test environment. I mean, in today's world, it should be super easy to just spin on your testing environment for this specific use case. Turns out in the last years, it's still not that easy as it looks like. So some people get to manage it, true. Some people really have to invest a lot of time into it, and some people just stop to even think about it. And this is one thing I can give you, like, we realize that most of the people, or a lot of our clients are turning the phase into really testing in production, not only under the principles of chaos engineering, but with having in mind, okay, if we understand production and if we really control how we can do the testing with performance tests, then we're feeling really safe and confident. However, this will answering this question will turn out for you. Highly recommend for the very, very first manual test sessions, please create something like a raw room. Put in the people from engineering, from operations, from QA, from product management, even from the business, and even somebody from the marketing. Just for the fact that the people realize, okay, this is how the team is working on this particular problem, to learning about the system and what the performance and scalability, and to make sure that we have like a good or high reliability, and to actually fulfill our requirements. And in this situation, which is like maybe like a 2-hour session, and it's not that expensive as you maybe think, you will learn that the people will get confident, okay, it's good that I have the right numbers, and some people realize it's good that somebody from the other team or the other application is here, so we can look in the system as well. Because this is one of the main points now. When you start testing, you need the visibility and observability of your system. So when you start your first test run, this should be something like which is really super easy. Just hit a button or send out an API call, and there you have load generators with your scenario, with your test data, which you defined, and the test should just create traffic, of course. And in this situation, this is probably the boring part of doing load tests in general, because now you can, if you want to, just look on load generator. But what maybe is a really bad idea is that you now deep dive in your own system, because what you can do here now in the very first place is realizing that you maybe should see all the errors you see from a load generator side, that you see all the requests, all the, I don't know, flowers you actually looked at, and all the product listings, and you don't realize, and this is the truth, like 95% of all first tests we do with one of our clients, or clients of us doing, is they're asking us something like, okay, you're probably wrong because I don't see this 500 here on my side, but I see it in your report. And we are for years are saying, okay, please check your monitoring and logging. And maybe sometimes hours and sometimes weeks later, turns out that there is something with observability. And this is one of the key facts in terms of operation, that if somebody want to operate a reliable system, then you must be confident and sure that you can see every single part of the system. I'm not saying that you really have to do a lot of logging, because this is, as we learned in the last year, is one of the baddest mistakes we can do, but that you know where you can look at, that you know where you can see it, and that you have the right alerting. And you will learn this definitely the first time. I mean, if you do the first test run and you do not learn this, please come back to me and tell me how you did that, because I'm really interested to do it. I'm pretty sure you will face this. Okay, I mean, after a session when you had like a test run with your team together, and let's say 20 minutes in this example here, then you of course recap what you had and saw in during your test in this test session, and you also get like a report. And this report is usually fancy and a lot of data in it with a lot of percentiles, and you can really get lost in during the interpretation of this data. And it's all important data, but in the first situation, I can highly recommend that you focus on something which is really important to you. And for example, like the easiest way is that you expect that you don't have any errors in this scenario, because if you have errors, you either have a problem with your scenario itself, or you have like a problem in the application, which you in worst case did not see in your observability or in your monitoring. And this is one thing you can check out. And the second thing, because it's pretty easy, is to find out, okay, are my response times okay? And you will probably find something where your response times are not that okay than you expect. And you can now maybe deep dive more into the reports, but again, would recommend to focus on some first key metrics. Because with this first results, it's important to actually tell the others, and by others I mean like probably the whole organization, about the first findings you had. And probably it's the best idea to put this in one statement where you say we aimed for these baseline numbers and we did that and that in this scenario, and we did like, I don't know, 4 times the traffic of a peak hour to make sure that we can stand that, because let's say we want to do this marketing campaign, but we see 20% of errors. And the fun fact, we did not see that 20% errors in our monitoring. So we investigating why we did not see that and have the first finding. And secondly, we have like the result that we know our response time, what the response time is, for example, 1 second in the 99th percentile. And now you're first of all done. But if you end that with the question, are you happy? I can say you that somebody you tell these numbers about will raise hand and ask, hey, actually, I'm quite happy with the findings, but please make sure that you can find these problems in monitoring and logging. Please make sure or tell me what to do if we want to have a response time which is under 1 second. And I can definitely tell you that people from the business, especially in an e-commerce example, will ask for something, hey, you did not test our checkout. And this is the most important thing for our business, because we don't need a flower listing if we cannot sell these flowers online, right? And now that's the point where you actually start iterating. You add the checkout, which is basically like adding like the post with JSON, or even with an HTML form, or just with an HTML form. You do another test run. And what you probably right now realize is this is like iterating over it and move forward. With that, you easily can explore the requirements from the business, from your colleagues around you, from the other teams, even so that you did not have like clear requirements beforehand, even so that nobody out there is saying, okay, I just want like a, let's say 50% reliable system, which is like answering in maximum of 5 seconds. Nobody's ever saying that. If you get to manage to move over that, people are happy, and I think it is cool. And all of our clients, for example, and all the people now who are doing load testing on a regular basis, they are feeling really comfortable with the behavior of their system under their circumstances. They actually imagine and try to find out and test for. So one step further, which is in our complex world right now, like a more bigger problem is after we found out what kind of requirements we had, that we can really check these requirements. So you can do something like define your non-functional requirements, where you're saying, okay, we expect no errors, so we expect every of the requests in the 99th percentile in under 250 milliseconds, for example. You can define this, and these checks, run them or check these NFR checks after a test run has been done. And with that, you can start automation and integrate that in pipelines. And now we're closing some cycle. If you do stuff like that, it actually looks like your test suite for functional requirements. You have violated the test. You have fulfilled tests. And if you really want to, you can create quality gates if you want to. My first recommendation is not really to use quality gates, but for some services, it's really important to do that. And I think that's the point when stuff is really getting cool, because we now learn that we can iterate over our scenarios. Whenever we create a new feature, we improve the scenario. Even for the non-functional tests, we can automatically run load tests, because we should not take care about like the load testing setup itself, but have like the right environment when we have the solution for that, of course. And you now have also seen that this is like one nice and big feedback loop. We always have like the feedback with the business and the stakeholders. Okay, is this the way to go? Is this really important for you? We can define requirements, which is transparent to all the people. We can work on the definition, the scenario itself. We have automated execution, and we learn over time a lot of data, which is comparable, and we can make decisions like, okay, right now a feature is for me more important than improving our performance. On the other hand, I know in the next iteration of software engineering, I really have to work on the improvement of our performance or scalability of the system to make the system more reliant. Sorry. So to round this up, so the last point is that when you have this, it's always a good approach and recommendation to create something like a community of practice or a special interest group, where you make sure that the people discuss these non-functional requirements, that you discuss their findings, because especially in organizations with a lot of teams, you realize that the one team is doing it like this way, the other team is doing it like this way, and they end up the same problem. I mean, this is like the basic idea of shared knowledge and making sure that everybody is going in the same direction. So I should end here with like good signals, but to be honest, like these are not the only challenges we had to face. There's even more stuff. As I said before, requirements will change and do change in a super innovative world, in a complex and cloudy environment. It's like this. Cloudy environments, it doesn't matter if it's just a cloud provider or a platform as a service or Kubernetes. These are complex systems too. These things change as well, and nothing of these is like at the final phase of the product, of course. And there are still like the normal philosophical questions around: should we start with this on a service level or component level to test, or should we do the first end-to-end test? This is not to answer. It highly depends on all the test cases, on the test situation, and you should ask yourself for that and find a conclusion somehow. And when it comes to the testing itself, you always challenge something. Like Marcus mentioned, like OAuth. So if you want to test that, it's really get complicated. If you have your own setup, I mean, you have a lot of challenges, announces you will send around. You can do that, but it really takes a lot of time. You have even more esoteric, not only protocols, but processes or frameworks. And at one point, you will definitely have some scripting needs. And this is like kind of the cutoff which I'm talking about by pragmatism over perfection. If you in first place think about like the fully fledged super 100% coverage test scenario for performance test, this will bring you a lot of trouble. On the other side, if you start easy, you will learn so many stuff on the way you making further, and when you move further, that you get confidence and have a better feeling, and of course more and better data to operate a reliable system. So altogether, start early, pragmatism over perfection, never forget that. Like in engineering, of course, if you have any assumptions, validate them, challenge these assumptions with your requirements, rearrange the requirements, that's no problem. Focus on your capabilities and the requirements you know right now. Don't wait for any requirements from somebody else. Make sure that you iterate on the scenarios and the test data, and that you have that, and focus on that to make that solid. Because if you want to have automated test data, this is like creating the new feature. Do the communication. I'm not saying have another meeting, because it's pretty easy. Some people have Slack channel for that. Some people just present in their Scrum flow demo or review. Hey, these are the current results of our performance test. Iterate on the scenarios and on the testing itself, as like in software engineering. and test often, of course. And this is like the best way to go if you automate it and integrate that. And like the happy land is if you start and let the sustainable performance culture evolve. So that's my talk. I say thank you very much. Thanks, Sven, for organizing. Thanks, Mike, for your talk. I'm still here as well for some answers. And Mike, if you want to, you can also write me an email.
All right. Thank you. Via the chat, we have no question for you, but except for myself. And but that's a question for both of you, Mike and Lars. So Lars was mentioning SLOs and SLAs, and let's say if you have an SLO or an SLA on performance or availability, you usually limit that to a number of requests per time frame. So let's say, you know, this service only works. The customer doesn't care, but to your internal customer, you say, okay, we developed this and we survive 1,000 requests a second. And how do you make sure if, you know, you just get a horrible overload, like clients behave very bad and from 1 second to the other, you have like 10,000 requests a second, which usually would break your service. So how can you protect your API from overload? So there is something like a load shredding or rate limiting. You know, what can you do, and how does it work?
So I have an answer from an operational perspective. So I think people who are into operating systems who maybe can't expect that, and even the people who think we will never expect that, should know what's going to happen when something like this happens. And there must be some mechanism in place to do that. For example, like you said, rate limiting, or like the old school way, create your or activate your maintenance page, or just configure your CDN to react on that. But here's the fun fact again, like if you do not test it, and if you can't imagine this thing, and if you do not think about it, then you will not know if it will happen. And this is what I meant by talking about confidence. And I think Mike probably will answer the same way. So some people say, okay, we create this API for a user base of, let's say, 10 people a day. And maybe they expose it, maybe not by design, maybe by mistake. And then it will get used. This is the hard way when they learn, okay, we should have like rate limiting or something like a maintenance page. I mean, in a website view. And by the way, I had this particular case 2 weeks ago. And it's about designing the API. So who's my audience? What is the business need? And is it really important for us? Because of course, I'm jumping in here for performance testing, but there are use cases out there where you do not need to have like a super setup of performance testing, but you should make sure that your systems will not go down when you get a lot of traffic for what reason ever. And these like two different perspectives. And you can test that out with performance testing, for example. But first of all, you have to you have to think about that in designing and asking yourself, what is my audience? Why, who are the people I'm doing that for? Do you agree, Mike?
Yeah, I mean, Lars has it just right. And I do see the same kind of thing. So this idea, you need to have some breaks, some kind of, we say guardrails like in English, right? Some basic elements that say, if you get past this level, start to either deny requests or slow them down or limit the rates, and maybe even just shut down a little bit. Or the opposite version of that is designing in a way that if we get an unexpected spike, I'm going to use cloud environments to spin up more responses. And I might have queues. I might design queues in between certain services so that I don't have to respond sequentially. I can do it asynchronously. So those are some design elements to be prepared. What you want to do is get yourself in a situation where some of this infrastructure is already in place. Some cloud environments can do this for you, or it can be relatively easy to alert you and speed up. So you sort of have a design, but you don't necessarily have to implement it right away. Because I think Lars mentioned this also, you don't necessarily have to build it on the very first day to like be like super large, but you have to have a preparation for it, an ability to turn rate limiting on, or the ability to reroute traffic, use a circuit breaker in some way. So it's definitely a mix. Most of when I work with groups, most of them, we do have on a service canvas, we have some SLA or objectives box. We have a non-functional requirements box, which where you list, it has to be auditable, it has to be backed up, and so on and so forth. And that goes directly to the performance team. That's the performance team's set, or they have to edit that space. So adding that as part of your design process is super, super important.